Now coming to the fourth problem of this simple harmonic motions chapter. The problem says that the statement is the length of a simple pendulum K. So suppose the length of a simple pendulum is effective length L of A is twice the length of a simple pendulum B, and suppose the length of simple pendulum B is L of B. So it says that length of a simple pendulum A is twice of length of simple pendulum B. So this is the condition given. The time period of the B is 2 seconds. Our time period given, this time period of the B is 2 seconds. What is the time period of the A? So we have to find out the time period of the A. So first of all, what will be the equation of time period for simple pendulum? It is 2 pi root over L by G, and this is for the simple pendulum A, and this it will be for the simple pendulum B. Okay, so this is equation 1 and this is equation 2. If I divide equation 1 with equation 2, then I will get T of A by T of B is actually equals to the root over L of A by L of B. So what is the value of L of A by L of B? We find out a relation between L of A and L of B, which is equals to the 2 L of B by L of B. Okay, so if I cut down this L of B, then I will get T of A equals to T of B into root over 2. And what is the value of T of B? T of B equals to 2. So it will be actually equals to 2 root 2, which will be equals to the 2.838 seconds. So this is the answer of our fourth problem. Now coming to the fifth one, it says that in order to increase the time period of a simple pendulum by 50%, how many times the effective length is to be increased? Okay, so how many times our effective length is to be increased? So suppose when the pendulum is in normal form, the time period is in first case, or in the normal case, our time period is T, and in the increasing case our time period is T prime. Okay, so we have to increase the time period of a simple pendulum by 50%. So what will be our value of T prime? T prime will be T plus we have to increase this 50% of T, which will be equals to the T plus 50 by 100 T, or it will be equals to the T plus half of T, and half of T is actually then I will get the value of 3T by 2. So our increasing time period will be T prime, so which will be equals to 3T by 2. So I just write this thing as 3T by 2. Just remove this thing. Okay, so I hope you understand how we get this value 3T by 2. In first case, our effective length is L, and in second case, our effective length is L prime. So how many times the effective length is to be increased, we have to find out. Okay, so suppose we say that at first case our equation of time period will be 2 pi root over L by G, and in second case our T prime will be 2 pi root over L prime by G. This is our equation 1 and this is our equation 2. So if I divide this equation 2 with respect to equation 1, then I will get T prime by T is actually equals to the root over L prime by L. Okay, root over L prime by L. So here, if I input this value of T prime, then I will get 3T by 2 by T equals to root over L prime by L. Then what I will get? I will get 3 by 2 equals to root over L prime by L. If I square both sides, then I will get root over if I square this both sides, then I will get L prime by L equals to the 9 by 4. L prime by L equals to the 9 by 4, or the value of L prime will be a 9 by 4 L. So the value of L prime will be 9 by 4 L. So I find out the what will be the value if I increase the what will be the effective length if I increase the time period of 50%. But I have to find out how many times the effective length is to be increased. So to determine this, so increased of length will be increased of length will be del of L, which will be actually equals to the L prime minus L. Here our L prime is 9 by 4 L and the value of L is L. So if I calculate this value, the value will be actually equals to the value of 9 by 4 equals to 2.25 L minus L, which will be actually equals to the 1.25 L. So it means the effective length is to be increased 1.25 times of L, or we can say that the effective length is, so 1.25 times we have to increase the length, or we can say that the effective length is to be increased by 125%. If I take this value in percent, then the value will be 1.25 per 125%. So this is the solution of our fifth problem. Now coming to the last one, the last problem says that the displacement of a particle varies with the time according to this relation. The relation is given that x equals to 4 cos of pi t plus sine of pi t. So this is a displacement equation of a particle varies with the time. So this is the varies with the time, and its value is in centimeter. Its value is in centimeter. So show that the motion of the particle is simple harmonic motion. So I have to find out this motion is simple harmonic motion, and its amplitude is 4 root 2 centimeter. So first of all, I have to find out the motion of the this what should I say, of this equation or of this displacement. So we know to prove anything is in simple harmonic motion, I have to prove this relation. Acceleration is proportional to the displacement and the direction is opposite. So I only have to prove this equation. Then if this equation can have this kind of relation, then we can say that this equation is simple harmonic motion. So first of all, we have to we should know the value of the velocity v. The velocity is differentiate with respect to time, then I will get d of dt, which will be equals to the 4 cos of pi t plus sine of pi t. If I differentiate this equation, then I will get 4 minus pi sine pi t plus cos plus pi cos of pi t. So this is the equation for our velocity. Then if I have to find out the acceleration, then I will again derive this equation with respect to time. Then I will get ddt of, if I minus pi sine pi t plus pi cos of pi t. So if I differentiate this equation will be equals to the 4 minus pi square sine pi t minus pi square cos of pi t. Okay. So if I take this value, then I will get a equals to minus 4 pi square sine of pi t plus cos of pi t. Okay. So if I take this value in that manner, minus of pi square 4 sine of pi t plus cos of pi t. We know the 4 sine pi t plus 4 cos 4 into sine pi t plus 4 cos not 4 plus 4 plus cos pi t is actually equals to the value of x. So instead, so for this we can write this x. So I will get the value x from here. So from that we'll get a is actually equals to the, so this pi is a constant value, then I'll get the equation is a is proportional to the minus of x. So this equation has this expression, so we can say that this equation is simple harmonic motion. Okay, so we just see that this equation is simple harmonic motion equation. Now coming to the second part, I have to show that the amplitude of this equation is 4 root 2 centimeter. So to calculate this amplitude of this equation, our equation are given is x equals to 4 cos of pi t plus sine of pi t. Okay, so we have to find out this amplitude. What is amplitude? The maximum displacement. The maximum displacement. So when a particle move as it maximum displacement, then the derivation of this maximum displacement with respect to time will be 0. So we can say that, or we can say that at maximum displacement our velocity is 0, because we know the equation of velocity is omega root over of a square minus x square. When x is maximum, when x is equal to its amplitude, then our velocity is 0. So from that we can say that when our velocity is 0, then it is in maximum displacement. So when our velocity is 0, it is in maximum velocity, maximum displacement. Okay, and this is our minimum velocity. So what equation we derive from this velocity equation? This equation is minus of 4 pi this equation 4 pi cos pi t minus pi sine of pi t, so it is equals to 0. From that we get that pi cos of pi t minus pi sine of pi t is 0, or we can write this thing as cos of pi t equals to sine of pi t. From that we can write this thing as tan of pi t equals to 1, tan of pi of t equals to 1. So when when the value of tan is equals to 1, when the angle is 45 degree, angle is 45 degree, or we can see this thing as when pi by t is 45 degree. So from that we find out that the pi by t is 45 degree. So what is the value of this pi by t? It is actually 45 degree. So if I put this value in this equation 1, then I will get x equals to 4 cos 45 degree plus sine 45 degree. Then I will get the value of cos 45 degrees is 1 by root 2, and it is also 1 by root 2, which is actually equals to the 4 into 2 by root 2. So if I cut this value, then I will get 4 into root 2 into root 2 by root 2 is actually 4 root 2. Okay, and when this value is 45 degree, when it is in maximum displacement, and this maximum displacement is known as amplitude. So this is actually represent our amplitude A. So we find out that our amplitude A is 4 root 2 centimeter, because this term is in centimeter value. So I find out that our amplitude is 4 root 2 centimeter. I hope you understand this math solution. We just described the overall topic of simple harmonic motion. Please like this video and do subscribe to our channel. Thank you.